Today we're going over how to replace the front brake pads on the first generation Toyota Sienna. It is strongly recommended to check the brake pads every 10,000 miles, and a complete replacement should be performed approximately every 40,000 miles to ensure the proper functioning of the vehicle's safety systems. Safety first. We want to keep our backs straight while working on a car. We lift with our legs, not our backs. And remember, we are working on vehicle safety components, so it is crucial to carry out this work professionally. We always try to get auto parts for the vehicle that are most updated and as close as possible to the OEM. Since we are working on a Toyota vehicle, it is recommended to use metric wrenches. We use gloves and safety glasses. New good quality front brake pads, OEM part number 0446545021. Also, new good quality rotor discs are highly recommended, OEM part number 43512-08021, usually comes without M8 openings. We're going to use 21mm wheel wrench, 17mm bracket wrench, sometimes a thin 17mm caliper wrench, 14mm caliper wrench, 8mm bleeder wrench, standard metric M8 bolt with 1.25mm thread pitch to loosen rotors, perfectly a torque wrench, wheel chocks, a floor jack, 2-ton jack stands, a wire hanger, a brake caliper press or a big screwdriver, even a hammer handle works, flat screwdriver, a wire brush, a pick or a dial indicator to check for runout, a file to balance the rotor, 5 wheel nut spacers, I got only 4 ones. Brake cleaner, silicone-based brake lubricant, unopened DOT3 brake fluid, DOT4 can also be used on this car. Printed to-do list. We'll start the process by working on the driver's side first. We are going to use the rear wheel as a balancing stand. Let's get started with securing the car. Before lifting the vehicle, place wheel chocks in front of and behind the right wheels. While the vehicle is still resting on the ground, we're going to use a 21mm wrench to crack open the wheel nuts. Trying to loosen the front ones with the wheel already in the air and the transmission in park puts unnecessary stress on the transmission. Then shift the transmission into neutral so the van can roll back slightly and rest against them. About an inch is enough. With the engine off, turn the key to the on position without starting the engine. 3rd position. Press the brake pedal and shift into neutral. It's easier to work on the drive wheels when the transmission isn't locked in park. Then we wedge the chocks tight against the wheels. Alright, now we raise the vehicle with a jack. We can use the factory jack with a drill adapter. If our drill isn't powerful enough, don't overload it. Raise the vehicle only until the tire is about to leave off the ground. Then finish lifting it with the factory jack handle. Or we can use a floor jack. This is the preferred option. We don't use a bottle jack. We always support it with jack stands. We never rely on a floor jack alone. the car can easily slip off the floor jack. Now we can unscrew the left wheel lug nuts. Note how easily the lug nuts go. Inspect them and inspect the wheel studs. Maybe some of them need to be replaced. If the wheel is stuck, we don't hit the rim with a hammer. Tap the tire from the back to release it. The wheel should loosen easily. So we remove the wheel and slide it under the car as an extra safety measure in case it falls. It's also good practice to thread on a couple of lug nuts to secure the brake disc, hand tighten only, so it stays seated properly and doesn't rattle against the bracket. I usually screw the left nuts onto the studs too, so I don't lose them. In the brake caliper assembly, hydraulic force transmitted from the brake pedal is used to press the brake pads against the surfaces of the disc. The resulting friction slows the rotation of the wheel. To easily access the bolts, we turn the rotor to the left using the steering wheel. Now we inspect the hydraulic brake hose. We check for leaks, fresh traces of brake fluid spray, cracks, or pinched sections. The hose should have a smooth routing and enough flexibility to accommodate suspension and steering movement without restriction. If the hose has failed, it must be replaced as soon as possible. Remember to check it before the caliper is removed. Next, we break the two 14mm guide pin bolts. Sometimes, a thin 17mm wrench is required to loosen them. It's best to break both bolts loose first and then remove them completely. Note how much force is required to loosen them. First, we unscrew the bottom bolt, then the top one, while holding the caliper to keep it from falling and damaging the hydraulic hose, but it usually stays in place on the brake pads anyway. Once the caliper is removed, we never let it hang by the brake hose or bend the hose sharply. We suspend it with a wire or place it on the rotor that won't put stress on the hose or scratch the rotor surface. If we're using a piece of wire, we wrap red or blue tape around it as a reminder that's a temporary thing. We do not disconnect the hydraulic hose from the caliper and do not twist it. It's also important not to press the brake pedal while the caliper is removed. Doing so can push the piston out of the caliper. A simple reminder note placed on the brake pedal can help prevent this. Now we wipe the inside of the piston duster. We don't use brake cleaner or something like that. If there is dirt in the system, it is usually displaced toward the bleeder. So, it makes sense to open the bleeder when pushing the piston back in, but we should be careful. We do not want to let air enter the system. We want to open the bleeder, push in the piston, and immediately close the bleeder. If air has entered the ABS system, it must be removed using a car diagnostic software. If you are unsure whether air is entering the system, do not open the bleeder. This can be done later during the final bleeding process. So, we compress the caliper piston almost completely. This returns it to its original position for new pads. The piston should move smoothly without binding, and the dust boot should be intact. We can put one of the old brake pads and a tire lug wrench or something like that and push on it. Or we can use a special tool to do this. If the piston retracts unevenly or feels rough, the caliper needs rebuilding or replacement. We compress the piston slowly to avoid stressing the system. After that, we close the bleeder. We don't want to get an air bulb in the system. We make sure the rubber boot is seated properly, not sticking out. If it has a bubble, it can be fixed by using a flathead screwdriver to carefully put the dust boot back into place. To remove the old brake pads and examine the wear pattern, we want to remove the anti-rattle springs. In my case, there are no springs. And then the brake pads along with the wear indicator clip, if it was present on the old pads. Uneven wear may indicate a problem. The most common causes are sticking slide pins or a partially seized caliper. If the pads are worn beyond the center slot, the wear indicator clip may have started contacting the rotor. In that case, resurfacing, machining, the rotor disc may help eliminate future squeaks. Standard front brake pad thickness is 11 millimeters. Minimum is 4 millimeters. If we use wear indicator clips, it can be more. We remove the old brake pad clips. Old pad clips can be reused after cleaning them up with rust remover or brake cleaner, especially if they are original. Some people even soak them overnight in vinegar or Coca-Cola. It doesn't make much sense to clean the brake clips too much. They will become just as dirty soon. Now we use a 17 millimeters wrench to loosen the bracket. Those bolts fit very tight. We want to be careful and not break the ratchet wrench. Once it loosens, we can clean the bracket up. We use a drill brush wire disc or a metal brush if rust has built up on the pad clips mounting surfaces. We do not use a file. If the bracket is too rusty, we replace it. Now we remove the slide pins and clean them up. If a guide pin is dry, rusty, or sticking, the brake pads may not release properly. This can lead to brake overheating, increased fuel consumption, boiling of the brake fluid, and even deformation of the brake disc. Some slide pins are equipped with a vibration damper rubber ring. If it falls apart, we remove any remaining pieces from the boot and repair or replace the pin as needed. We clean the inside to ensure there is no dirt or debris. Now, we inspect the rubber dust boots on the guide pins. If a boot is torn, water and road grime will quickly penetrate, leading to corrosion and wear. Wipe the inside of the rubber dust boot. And we need to be careful, this rubber is very thin. A dust shield is located behind the brake disc. It prevents stones, road debris, and water from reaching the disc surface. When cornering, whether turning left or right, slight play develops in the wheel bearings. This causes the brake disc to shift, potentially leading the shield to rub against it and leave scratches. If fresh scratch marks exposing bare metal are visible on the shield, this is the source of the noise. We can now check the clearance. If it is too narrow, for example, around 1 millimeter, it should be increased to 3 to 5 millimeters. To do this, we use a flathead screwdriver to carefully bend the shield away from the rotor disc. We mark the brake rotor and wheel hub for reassembly. Marking the current position will help prevent runout caused by accumulation of tolerances. Now we inspect the brake rotor. Deep grooves, excessive wear, or signs of heat damage, warped brake disc, may indicate that it is time for resurfacing or replacement. Many shops that perform wheel alignments can also machining, resurface, brake rotor discs. Minimum thickness is 26.0 millimeters. If the rotor thickness is 26 millimeters or less, it should be replaced. Now we temporarily remove our holding lug nuts. To remove a stuck rotor, we try not to use a hammer. The rotor usually has 2 openings where we can put a metric M8 bolt to loosen it. Sometimes, original parts come with no specific openings, so we can try inserting a bolt between the back and the brake disc and screwing it in to press the disc off. And place the old brake pad between the bolt and the disc to protect it. In my case, the disc loosens easily. It's important to remove rust or corrosion from the mating surfaces. Now we can take a wire brush and clean all contacting surfaces of the rotor and hub, but we do not try to achieve perfect cleanliness. We don't want to grind away too much metal. We use an abrasive pad and a drill for cleaning around the wheel studs. We should never remove more material than needed or produce sparks while cleaning the rotor. Before reusing the brake disc, we ensure that both of its mating surfaces, inner and outer, are cleaned of rust and contaminants. We try to save the reassembly mark. It's important to remove rust or corrosion from the hub face. So we take a wire brush and clean the hub face, but we do not try to achieve perfect cleanliness. We should never grind away more material than needed or produce sparks while cleaning the hub face. If we need a repair manual, we can search for it on Google or the charm.ll website. I'll try to share the 1998 Toyota Sienna V6-3.0L1MZV service manual in that video description. We don't touch new rotors or pads. These parts must be kept as clean as possible. So we go ahead and wash up our hands and get new gloves. An old wheel hub may exhibit significant runout. So we want to verify this. Because the hub is smaller than the rotor, the runout must not exceed 0.03 millimeters. We can use a dial indicator to check for runout, or we can use a jack stand and something like a pick. We position the measuring tool so it barely touches the outer edge of the disc surface. We're going to place it as close to the edge as possible, avoiding contact with rust or irregularities near the base. Ideally, we will hear a characteristic continuous scraping sound while rotating this, rather than cutting out. Tolerances are very tight, thinner than a human hair. And we want to spin the hub very carefully, trying not to rock the vehicle. Whether the brake disc is new or used, its balance must be checked. To check it, mount the disc on the rear hub and spin it. make sure the parking brake is released. Another important point, we need to ensure that the rotor is centered. If the rotor stops in the same position every time, it needs to be balanced. Many shops that perform wheel alignment also offer brake disc balancing services. Caution: do not perform the following step unless you are certain you fully understand the procedure. We can adjust the balance using a file. Carefully file the edge between the two disc plates to achieve balance. we securely fasten the disc to the front hub with our 5 spacers and 5 lug nuts. This is an important step. We want to ensure that the rotor disc is securely installed. We tighten it to the required torque of 79 foot-pounds. Now we spin the rotor and check the brake disc for runout. And we want to spin the rotor very carefully, trying not to rock the vehicle. The runout must not exceed 0.05 millimeters. The disc is fine if the measured runout is less than 0.05 millimeters, 0.002 inches, which is roughly equivalent to the thickness of a human hair. If the runout isn't so bad, we can try reinstalling the disc by rotating it 1/5 of a turn relative to its original position on the hub. We install the hub nuts and tighten them to the required torque of 79 foot-pounds, then take measurements. Once the optimal position is found, we can secure it in place. In my case, the runout is well outside the acceptable limits. With this much runout, we will experience a vibration that feels much more intense than we'd expect. So this disc needs to be replaced. The new rotor has to be checked for runout as well. We install the rotor disc in place and clean it up with brake cleaner, taking care not to touch it with our hands. Our holding lug nuts should be placed. Now we're going to install our pins. They should move smoothly and freely. If there is too much grease on them, that can also be a problem. We apply a small amount of silicone-based brake grease to the sides, not the tip. As we install it, we push it all the way down, letting the air come out. Perfectly, they pop out on their own, but not all the way. One of them has an amortized rubber ring. This one goes on the bottom. We want to be sure every pin is working properly. When pressed, it extends, and when pulled, it retracts. Now we install the bracket. As we recall, the part was a very tight fit, so we make sure it doesn't work itself loose. We aren't afraid of breaking it, it's a rather large bolt. Now, the torque is going to be 79 foot-pounds. We carefully inspect the new brake pads, especially if they differ from the original ones. I initially installed the pad clips supplied with the aftermarket brake pads. Some of the tabs on the clips for the new brake pads were oversized and featured adhesive pads approximately 1 millimeter thick. In my case, these pads were not required, so I removed them. They're probably intended for heavily corroded brackets that have been cleaned up with a file. Later I switched to the pad clips from my new Caliper hardware kit because they matched the factory design very closely. The first hardware set would have worked, but it didn't really go well with my brackets. All pad clips should be fully seated and secure, should not contact the rotor, and the pads should slide freely enough to retract from the rotor when the brakes are released. Basically, original pad clips should work well for us even if they're old. I experimented with all 3 sets of pad clips over the course of more than 5,000 miles, and all 3 perform roughly the same, but I decided to use ones that come with the Caliper kit. Attention! Do not do the following step unless you are sure you clearly understand it. I carried out this step as an experiment. Adjust the pad clip tabs as necessary so the pads move freely without sticking. Pay attention to pad clip depth. If the pad clips can move far enough inward to contact the rotor when the brakes are applied, it's going to be scraping noises while stopping. Bend them slightly backwards if necessary to maintain proper clearance. Slightly bend long pieces to prevent rotor scratches. Bend them backward from the rotor but keep the pad mounting surfaces nice and flat. Double check everything before reassembly. If you are unsure how to do this step, simply get a new set of genuine brake pad mounting hardware. We don't get the new pads dirty. Before installing the new pads, we always compare them with the old ones to verify the shape and dimensions are correct. Even brand new parts can occasionally be wrong. So we try to get auto parts that are as close as possible to the OEM. First-generation Siennas typically do not have additional brake pad shims, so their installation is not required. The wear indicator goes at the upper rear pad. It has to be the first thing that is touching. We make sure the pads move freely before the caliper is installed. While holding pads, place the springs. We make sure the hydraulic hose isn't twisted. The bolts should be tightened securely, but we don't overdo it. We don't want to damage the threads. Sometimes we need a thin 17mm wrench with 14mm to tighten. The guide pins must move freely while remaining secure enough not to loosen from vibration or road impacts. This is a safety component. The torque is going to be 25 foot-pounds. And we don't forget to remove the holding wire. If the spacers are still there, we remove them and remove our holding lug nuts to install the wheel. We thread on the lug nuts while the vehicle is still raised. Then lower the van. And perform the final tightening in a crisscross pattern once the van is on the ground. There's no need to over-tighten them. We don't want to stretch or break a wheel stud. Torque is 77 foot-pounds. I couldn't find a 21mm socket, so I'm using a 13/16" one. It fits the lug nuts a bit more snugly. We check the brake fluid level in the reservoir. If the DOT3 fluid level is low, we top it up. As soon as the reservoir empties, air will enter the system. It is also useful to clean the lid. Now we can remove the note from the brake pedal. Pump the brake pedal, even if we have finished working on only one wheel. This could save a life. After that, we repeat the same process on the other side. We'll chucks. Break all the right lug nuts. Neutral. Raise. Jack stands. Unscrew lug nuts. Remove wheel and slide. Lug nuts. Turn the wheel rotor to the right. Inspect the hose. Break 14mm guide pin bolts. Remove them. Hang the caliper up. Reminder note. Rubber boot. Bleeder. Press caliper. Anti-rattle springs. Remove pads. Inspect them. Remove pad clips. Clean them up. 17 millimeters. Wire brush. Remove slide pins and clean them up. Clean up the inside. Inspect rubber dust boots. Inspect the dust shield. Fix clearance if needed. Mark rotor and hub. Inspect rotor. Remove our lug nuts. M8 bolt or back pushing. Wire brush. Save the mark. Wire brush. Keep hands clean. Hub run out. Check the balance. Five spacers and lug nuts. Run out. Clean up the rotor. Silicone-based lubricant. Rubber pin goes on bottom. $17 millimeters. $79 foot-pounds. Make sure the clips fit. Rotor clearance. Don't get the pads dirty. Wear indicator at the upper rear. Make sure the pads move freely. Springs. Keep the hose straight. $14mm. $25 foot-pounds. Remove holding wire. Remove 5 spacers and 5 lug nuts. Thread on the nuts. Lower the car. $21mm. 77 foot-pounds. Check the fluid level. If it is slightly above the max mark, it is not a problem, as the level will return to normal after the engine is started. Remove the note. Pump the brake pedal. It is recommended to flash the brake fluid every 20,000 miles. After a simple pad replacement, we normally do not introduce air into the brake system if we didn't change any components such as the caliper, hydraulic hose, or master cylinder. If we want to make sure there is no air in the system, we need to bleed it. Air makes the brake pedal feel soft and unresponsive, known as a spongy brake pedal. Bleeding is done through the bleeder screw located on the back of the caliper. On older calipers, bleeder screws often seized in place, so we loosen them carefully. A little penetrating oil ahead of time can help us. We can usually loosen the bleeder screw without removing the wheel. It's located near the brake hose and can often be found by feel. We can use a one-way bleeder hose, which allows fluid to flow in only one direction. Just make sure no air enters the system through the hose, bleeder screw, or an empty reservoir. We keep the reservoir topped off throughout the process. We do not use an old, pre-opened container of brake fluid. I'm using DOT3 brake fluid. DOT4 can also be used on this car. One advantage of bleeding the brakes is that the more old fluid we push out, the more fresh fluid we replace it with. It's always worth checking the condition of the fluid in the reservoir. It should be clear and free of sediment. If the fluid is dark, cloudy, or contaminated, consider draining the reservoir and performing a complete system flush. In my case, a full flush required about 2.5 quarts of brake fluid. I'll leave links to the PDF files containing the to-do list and manuals in the video description below. If you found this video helpful, don't forget to hit the like button and subscribe. And if you enjoy working on your car yourself, I'll be posting more videos like this in the future. Thanks for watching, and I'll see you in the next video.